Student, today we are going to learn how to derive the elastic collision derivation, the object of final velocity of object 1 and also final velocity of object 2. When the two object is colliding, it's going back with the final velocity. We are going to learn what is the equation for the object 1 and object 2 in elastic collision. There are two types of collision is there. One is elastic, another one is inelastic. Today we are going to see elastic collision derivation. Okay, these are the equation we are going to learn how to derive. Okay, actually it's very simple to derive. Okay, and also with the special case for the elastic collision, when the two object is colliding, both the mass is equal. What's going to happen? Initial and final velocity. When the initial velocity of object 2 is 0, now the same time mass 1 and mass 2 will be equal. Now what is the final velocity of the both the object? Okay, the third case, m1, the mass 1 is very lesser than the mass 2 and final velocity of initial velocity of object 2 is 0. Now what is the final velocity? These are the case we are going to discuss. Okay, now first we will see what is a collision and types of the collision. Collision, when the two ball is colliding each other, we can call it a collision. When the two ball is colliding each other, we are going to call it a collision. Okay, so after it collides, it's going to get with a different velocity and it's going to back. Okay, it is a final velocity of object 1, it is a final velocity of object 2. This equation only we are going to derive. Okay, when the two objects collide, there are two types of collision is possible. One is elastic collision, another one is inelastic collision. Elastic collision is a rigid collision. Two, like a metal ball, it is going to be collide each other. Consider sound energy and heat energy will be the negligible. Okay, it's going to come back with the final velocity. That is the elastic collision, which is called rigid collision. There is no loss in momentum, there is no loss in energy. Both will get conserved. Okay, but inelastic, it is a non-rigid body collision. Okay, rubber ball is an example of inelastic collision. Is not conserved. Momentum will be getting conserved. Momentum is always conserved. Okay, but energy is not conserved. Okay, energy is not conserved. Energy is not going to be constant because the energy is going to be changed because of change in dimension or change in energy. Okay, or change in shape. Okay, when the two rubber balls is colliding, the shape is going to change. That also is an example. Okay, elastic collision example, two rigid bodies colliding each other, otherwise two atoms is colliding each other, we can take it as a elastic collision. Inelastic collision, we can take it as a car is an example. Normal car only is example. The otherwise we can take it as an example is a rubber ball. Okay, so it is a inelastic collision. Okay, rubber ball. Now we are going to see elastic collision derivation. Okay, if you like my channel, please subscribe. Okay, this only, as I said, v1 velocity, v2 velocity, we are going to derive. Okay, so imagine object 1, m1 mass with the u1 velocity. Again, object 2, m2 mass with u2 velocity. Both is colliding each other. Both is colliding each other. After collision is going to come with the opposite side. Okay, it's going to come like this. It may be any example. Okay, m1 mass with v1 velocity, m2 mass with v2 velocity. After collision is going to come back. Okay, now this what is happened. Okay, now I said conservation of momentum and conservation of energy. It's going to be the elastic collision. Right now we are discussing with the elastic collision. Okay, first is the momentum is getting conserved. Okay, momentum is getting conserved. No, before momentum is equal to after momentum. Before momentum means it is momentum is going to be mass into velocity. Before momentum m1 u1 plus m2 u2 before momentum. After momentum m1 v1 plus m2 v2. Before momentum is equal to after momentum. That is a conservation of momentum. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. It's very simple. Okay, so two ball is colliding, just I wrote as the equation. Okay, now all m1 mass in a one side, m1 u1, so this equation I am taken this side, this equation I am taken this side, minus m1 v1 is equal to m2 v2 minus m2 u2. Just I made modified. Okay, this I am bringing here minus, I'll get this I am bringing here, I'll get as a minus. That's it, remaining as it is like that. M1 I am taken common, u1 minus v1. Here m2 is a common, v2 minus u2. So I got equation 1. So this is the equation 1 I am going to use in many of the places. So the same equation we are going to use in to find v1 and v2 velocity. It's a very important equation. v1 equation I got. Okay, now energy is conserved. Before energy of m1 u1 square plus of m2 u2 square. Kinetic energy of mv square formula before collision m1 u1 m2 u2 of m1 v1 square plus of m2 v2 square. All of it's going to get cancelled. Okay, of get cancelled, left hand side right hand side of get cancelled. Okay, remaining whatever is there I am writing like that, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 square 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 square. And now also I am bringing all m1 as a one side, all m2 as a another side. Okay, so that means this is m1 I am bringing this side, this is m2 I am bringing that side. Okay, plus is going to become as a minus m1 u1 square minus m1 v1 square, because this is came this side, is equal to m2 v2 square minus m2 u2 square. Okay, just I got like this equation. Okay, here also m1 is common outside, u1 minus v1 square is equal to m2 v2 minus u2 square. This what we'll get. Okay, so it is a minus b, a square minus b square is equal to a plus b, a minus b. It's very simple equation. Okay, so now here we are going to write a plus b, a minus b. Okay, here also we are going to write a plus b, a minus b. See how I am writing. m1, okay, this side is a u1 plus v1, u1 minus v1, just a plus b, a minus b is equal to m2 v2 plus u2, v2 minus u2, just a plus b formula, a plus b, a square plus b square formula. Now I got equation number 2, just I'll write here equation number 2. Equation number 2 we got, okay, equation number 2 divided by equation 1. Okay, just a direct division. Equation number 2, this I am taken as equation number 2. Already I said equation of number 1. Okay, now we are going to divide both the equation. So when we are dividing equation 2 and 1, first we will write the equation 2. m1 u1 plus v1 u1 minus v1 is equal to m2 v2 plus u2 v2 minus u2 divided by equation number 1. So already I said equation 1 is a very important equation, just keep it in mind. m1 u1 minus v1 m2 v2 minus u2, just this get cancelled, this get cancelled, this get cancelled, this get cancelled. u1 plus v1 is equal to v2 plus u2. This what we'll get. In case you want v1, v1 is equal to v2 plus u2 minus u1. In case you want v2, when you want v1, u1 bring it this side, you will get negative. When you want v2, u2 bring this side. Okay, it will become as negative. So u1 plus v1 minus u2 I am bringing this side, u2. Okay, now we got v1 and v2 equation. Actually this equation is not a final. Why it is not final? No, because v1 v2. Okay, when you are writing v1 equation, we got v2 relation. Okay, both is unknown quantity. So when you are given in a single equation both is unknown quantity, the equation is not going to be used anywhere. Okay, so v2 we have to change it, we have to change the other format. Okay, I'll repeat again. We need both the value. Okay, this also unknown, this also unknown. In single equation two unknown terms is there, it's very difficult to find. Its equation is not going to use anywhere. Okay, so we have to know all the terms, then only you are easily you can find. v2 also we don't know, v1 also we don't know. Okay, just I am going to find this equation. Already I showed you this equation. If you are deriving, these are the noun quantity, everything is a noun quantity. Okay, this only I am going to derive. Okay, the first one, to find v1 velocity, to find v1 velocity. I don't know what is v1 velocity. This is a time we have to substitute the v2 equation in equation number 1. In equation 1 you should substitute v2 value if you want v1. Okay, the opposite way, if you want v2, substitute v1 value in the equation 1. Okay, very simple. Okay, so I have both the equation v1 velocity and v2 velocity. Okay, I know what is the equation 1 also. Okay, now we are going to find what is a v1 velocity. If you want v1 velocity, just you should substitute v2 in a equation 1. Okay, I know equation 1, just I'll write equation 1. So m1 u1 minus v1 is equal to m2 v2 minus u2. Now I am going to substitute what is a v2 value. Okay, so see here v2 also I am going to show you. V2 value also already we found. V2 is equal to u1 v1 minus u2. Okay, so you have to be very careful when you are substituting the value. So m2 u1 plus v1 minus u2, because so v2 value I substituted, v2 value I have here. Okay, already we found v2 value minus u2. So this u2 I am writing here, this minus I wrote here, is equal to m1 u1 minus m1 v1. Just I am taken this m1 as a inside, very simple. Okay, this m2 also I am going to take it inside. So minus u2 minus u2 minus 2 times minus 1 minus 1 minus 2. Okay, like that you will get m2 u1 plus v1 minus 2 times of u2, because x it's a minus x minus x minus 2x, like that will get. M2 I am bringing inside, m2 u1 plus m2 v1 minus m2 2 times of u2 is equal to m1 u1 minus m1 v1. Same I wrote here. Now we are finding what is v1. Bring all v1 as a one side. So this v1 I am bringing this side. Negative is going to become as a positive. Okay, so is equal to m2 v1, it's here, minus going to become as plus m1 v1 I am bringing left side to right side. Okay, so I got this value. The next thing, remaining terms I am bringing as a left side, m1 u1. This if you are bringing as from here to here, negative will get. This if you are bringing here to here, you will get as a positive. So it's going to be minus m2 u1 minus is going to become as plus. Minus, when it's going to become as plus, it's going to be 2 times of m2 u2. Same equation, just I modified. All v1 I brought one side, all remaining others I am bringing as another side. Okay, just a modification of above equation, this equation. Okay, now here u1 is common, m1 minus m2 into u1. u1 you can take it as a common from both the place, plus 2 times of m2 u2 is equal to, here v1 common, v1 m1 plus m2, very simple. Now I should do the cross multiplication. Okay, this I am bringing as a denominator. We'll get as a what is v1. v1 is equal to whole denominator m1 plus m2. It is m1 minus m2 into u1, just this one, plus 2 times of m2 u2. This is a common term for both the place. You can write as a common equation. Okay, so right now we will get what is a v1 value. v1 is equal to m1 minus m2 u1 divided by m1 plus m2 plus 2 times of m2 u2 divided by m1 plus m2. We got what is the equation, first equation. So in elastic collision we got first equation. See here, we got the first equation. Okay, so we got first equation, simple. Okay, so now second equation I am going to do. Okay, before going to second equation, I will give simple trick to find the second equation. Similarly, v1 is equal to v2, m1 is equal to m2, u1 is equal to u2. If you are taken this, okay, if you are taken this, it's going to switch. It's a simple trick. Okay, v1 is equal to v2, m1 is equal to m2 minus m2 is equal to m1, u1 is equal to u2 divided by m1 is equal to m2, m2 is equal to m1, plus just I am modifying the above equation, 2 times of m1 u1 divided by m2 plus m1. This is a v2 equation. You can write, it's a simple trick, but I am going to teach you how to derive this equation also. Okay, so this also very simple to learn. Okay, already I said, okay, in a previous case I given one trick. If you want v1 velocity, substitute as a v2 velocity in equation 1. Now I am going to find v2 velocity I want. Substitute v1 velocity in equation 1. Okay, I know already what is v1, what is v2. Okay, just I will show what is v1 and v2 velocity. Now we know what is v1 velocity and v2 velocity. Already we derived. Okay, it's the equation we derived. Okay, v1 and v2. Now I am going to find v2 velocity. Okay, when you want to find v2 velocity, v1 equation substitute, v1 you have to substitute in equation 1. So what is equation 1? That also we have already, equation 1. Okay, this is equation 1. So m1 u1 minus v1 is equal to m2 v2 minus u2. This is equation 1, already we derived this. Now I am going to substitute v1 value. v1 value is equal to, v1 also we have v2 plus u2 minus u1. This I am going to substitute here, v1 value. Okay, so m1 u1 minus v2 minus plus u2 minus u1 is equal to m1 v2 minus u2. This is what we have. Okay, just I am taken as a m1 inside, this minus first I am taken inside, m1 u1 minus v2 minus u2 plus u1, u1 2 times of u1 will get. Okay, m1 v2 minus m1 u2. This is what we have the equation. Okay, now u1 2 times of u1, so m1 2 times of u1 minus v2 minus u2 is equal to m1 v2 minus m1 u2. Okay, this is what we have. m1 I am bringing inside, 2 times of m1 u1 minus m1 v2 minus m1 u2 is equal to m1 v2 minus m1 u2. This is what we have. Okay, now the same, all v2 bring as a one side, this I am bringing this side. Okay, all v2, this is v2, this is v2, m1 v2 plus m1 v2. Okay, sorry, it is m2 value, it is m2, I made small mistake, it is m2, all v1 I am bringing this side. Okay, all v2 I am bringing as a left side, so this is become as a right side, from left hand side to right hand side it's become. Okay, now this I am bringing right side to the left side. Okay, negative sign is going to become as a positive sign, remaining as it is, 2 times of m1 u1. Okay, then minus m1 u2 plus m2 u1. This what we have, sorry, u2. Okay, this I am bringing this side. Okay, u2 here it's common, you can take it outside, v2 here it's common, you can take it as a outside. Okay, just I want to show what is going to happen. It is 2 times of m1 u1 plus, just I am taken u2 common outside, u2 I am taken common, m2 minus m1 u2 common outside is equal to v2 I am taken common outside, m1 plus m2. So this I am bringing as a denominator. Now it is again, it's a very simple, what is v2? v2 is equal to, just I am bringing this denominator, m1 u1 divided by m1 plus m2 plus m2 minus m1 into u2 divided by m1 plus m2. We got now what is a v2 equation also. Okay, in elastic collision, now we learned what is v1 and v2 equation. Okay, both equation we derived. Okay, now I am going to teach you what is the special cases. There are 3 special cases I am taken. Okay, so first special case is both the mass is equal, m1 is equal to m2. Now what is the v1 velocity and v2 velocity? This is what we are going to discuss beginning. Okay, so both the velocity is equal, both the mass is equal. Now what is the v1 velocity, v2 velocity? So first we will find first case, m1 is equal to m2. Okay, now what is v1 velocity? m1 is equal to m2 means this will be 0. 0 into anything will be 0. 0 plus 2 times of m2. When this 2 equal, no, it is a 2m. Okay, because it's common. Okay, m2 get cancelled, it's going to be u2 to get cancelled. v1 is equal to u2. It's very simple. When m1 is equal to m2. Now we will see v2. When this 2 is equal, it's going to be 0. Okay, this 2 equal, no, equal term will get cancelled, 0. Okay, so v2 0 is equal to 0 plus, so 2 times of m1, 2 times of m1 u1, same, this 2 equal, no, it's going to be 2 times of mass, 2 times of mass, get cancel. So v2 is equal to u1. So just u1 velocity is going to change as a v2 velocity, v2 velocity is going to change as a, u2 velocity is going to change as a v1 velocity. Just interchanging the velocity. Okay, this velocity is going to get with this object, this velocity is going to get with this object. Okay, like this is going to happen. Case 1. The first case is over. The now second case, v2 velocity is 0, at the same time m1 is equal to m2. We'll see what is going to happen. Now u2 is 0, second velocity is 0, m1 is equal to m2. Okay, so u2 is 0. So now what's going to happen with v1 velocity? Second case, m1 is equal to m2, u2 is equal to 0. Okay, now what is a v1 velocity? When this 2 is equal, this will be 0, 0 into anything will be 0, 0 plus, so this 2 is equal, 2 times will get, u2 will be 0, 0 into anything will be 0. Okay, 0. So v1 velocity will be 0 for second case. Okay, again v2 velocity, we'll see v2 velocity. This 2 is equal, will get 0 plus, okay, so now it is 2 times of m1 u1. This 2 is equal, this 2 is equal, we can add this 2, 2 times of m1, get cancel. So v2 is equal to u1, v1 is equal to 0. Okay, v1 is equal to 0, u2 is v2 is equal to u1. It's a very simple equation. We got second special case also. Now we are going to do with the third special case. Okay, third special case. What is the third special case? See here, m2 is very greater than m1. Okay, at the same time u2 is 0. m2 is very greater than m1. m1 is very lesser than m2. m1 is approximately 0. At the same time u2 will be 0. Now what is going to happen? We'll see. Special case, third special case. We can give a number of special case, just I am given most important special case. So v1 velocity, what's going to happen? No, so we are taken m1 is 0, so 0 minus m2 divided by m1, 0 plus m2 into u1 plus u2 will be 0, this whole term will be 0. Okay, so we'll get m2 get cancel. So v1 is equal to minus u1. Okay, now v2, what will get v2? We'll see. u2 as a 0 we are taken, this fully 0, 0 plus 2 times of m1 u2 divided by, here no, which is which will be the 0. We are taking m1 is 0. Okay, approximately m1 is 0 means this m1 will be 0. So this whole equation will become as 0. So 0. Okay, so v1 velocity is minus u1. v1 velocity is going to be for this case minus u1. v2 velocity will be 0. You can have a number of special cases I am given with the most important special case. Thank you for watching my video. If you like my channel, please subscribe. Thank you everyone.